Karen, for a check on the current weather in Baikonur. What can you tell us?
The most recent weather readings I've received are cloudy skies. We have a liftoff temperature range of 25 to 27 degrees Celsius or 80 to 84 degrees Fahrenheit. The ground winds are coming from the north at 5 to 8 meters per second. Now the upper level winds are all within limits at all altitudes. So weather conditions in Baikonur are ideal, and currently we are go for launch.
Thank you, Karen. Don Harms, Vice President of Sales, Marketing and Communications at ILS, sends us this message from Baikonur.
Hi, I'm Don Harms, Vice President of Sales, Marketing and Communications for ILS. We are honored to be here today for the SES-6 launch, our 22nd for SES, and our 16th with Astrium. I'd like to take this opportunity to thank all the people who have worked so hard over the last couple of years, from Krunechev, ILS, SES, and Astrium. Thank you so much. Spasiba.
Now let's take a chronological look at SES-6's journey to launch.
Typically, it takes about 2 years for the launch vehicle and satellite to be built, tested, and shipped to the launch site. From crew and spacecraft arrival, it can take from 4 to 7 weeks to complete a launch campaign. Today's launch begins with the early team arrival in Baikonur. The spacecraft arrives aboard an Antonov cargo jet at Yubileyny Airfield. The spacecraft is offloaded from the plane and placed onto a railroad car. The thermally controlled rail car is hooked up to maintain the proper environmental conditions for the spacecraft during the 6-hour trip to the launch processing facilities. Once in the high bay, the spacecraft team does a series of system tests and other standalone operations, including fueling the spacecraft. Fueling of the spacecraft is then completed. The satellite is then mated to the Breeze-M upper stage and rotated horizontally to be encapsulated in the payload fairing in Hall 101. The spacecraft, fairing and upper stage are now referred to as the Ascent Unit. The entire assembly is mated to the booster stages of the ILS Proton launch vehicle in Hall 111. The integrated launch vehicle is rolled to the Breeze-M fueling station, where fueling of the Breeze-M is completed. The complete rocket rolls out to the launch pad, where the entire vehicle is changed from its horizontal position on the rail car to a vertical position on the launch pad. Then the service tower is moved into position. The mobile service tower provides services and accessibility to the launch vehicle and spacecraft. Proton rollout to the pad always occurs at exactly 6:30 in the morning, corresponding with the precise time the vehicle for Yuri Gagarin rolled out in 1961, marking this landmark anniversary in space advancement.
And now my co-host Karen Young will take us through the final pre-launch preparations and through liftoff of SES-6. Karen?
Jennifer, in addition to those at the launch site, there are many others watching who have played an important role in the SES-6 mission, and we'd like to say thanks for all your hard work in getting to this moment. SES in Luxembourg, Astrium in Toulouse, France, Astrium UK propulsion team, who are from Stevenage in the United Kingdom, Krunechev in Moscow, ILS headquarters in Reston, Virginia, and of course all the others who have helped make today's launch of SES-6 a reality. Today's launch of the SES-6 satellite on ILS Proton is the result of an accumulation of a lot of hard work and long hours, and everyone on the launch team is eagerly awaiting the liftoff. Teams are in their places in the launch bunker, the control rooms, ground stations and communication centres. And the final go for launch polling we mentioned earlier is being completed. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Ignition start, we have liftoff of an ILS Proton rocket from pad 39 at the Baikonur Cosmodrome in Kazakhstan with the SES-6 satellite on board. It can be a little difficult to see, but at about 10 seconds after liftoff, the rocket does a roll maneuver and will soon experience maximum dynamic pressure, which is the maximum aerodynamic load on the vehicle. For Proton, it corresponds to about Mach 1.6 and occurs at 1 minute, 2 seconds after liftoff. Everything seems to be proceeding nominally as the vehicle heads across the Cosmodrome vertically in the northeasterly direction with a flight launch azimuth of approximately 61.3 degrees. It's an absolutely glorious day in Baikonur, and the viewing for all the teams on the ground will be absolutely spectacular. They could probably see this as far as the eye can see. We're coming up on the first stage's separation from the second stage that is set to occur at 2 minutes into the flight. Watch for the halo effect as the second stage engines ignite prior to the separation from the first stage. And we have confirmation of a good separation between the first and second stages. I've got it. We have a signal of ignition on all 4 second stage engines. They will burn for a total of about 3 minutes and 27 seconds. The next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27